Scientific notation is the convention that we use to abbreviate huge and tiny numbers. Here's a huge number. I don't think you'd want to write that out. In fact, a lot of people make mistakes when they write down this many zeros because it's really easy to miscount and add one or leave out one. So scientific notation is a convention that changes the number to a multiplication problem where we get rid of writing out the zeros and we count them instead. Here's what it looks like. First, you express the number as a value between 0 and 1. That means you need to put the decimal after the first digit, okay? And we keep all of the number until we get to just zeros remaining. So this is how much of the number you're going to write down, and you stop writing all of these zeros. But that doesn't work unless you take that number and multiply it by some power of 10, which is like putting all the zeros back, but in a really clear, precise way. So how many decimal places would we have to move it to get it back to its original state? And I'm going to count from the 0 end, which is 3, 6, 9, 12, 13 places. And that's why this is 10 to the 13th power, because that's like multiplying 2.6 times 10 repeatedly 13 times. Okay, here's another big number. This is the distance from Earth to Mars in kilometers. So first we change the decimal so that it comes after the first digit. We drop all those extra zeros, but instead we need a power of 10 that would put them back. So from here you ask yourself, how many places would I need? 3, 6, 7, 8. So that's 10 to the 8th power. And that is scientific notation. All right, let's try a really tiny number. The fairy fly is the smallest insect that's been measured so far. And here is the length of a fairy fly in inches. So we still put the decimal after the first significant digit. So we're going to change it to 5.9. Now, if we start multiplying that by 10, it's going to get bigger and bigger and bigger, and we want it to get smaller. So we're actually going to divide by 10 repeatedly. And you can show divided by 10 by using a negative exponent. How many places different is this? 1, 2, 3. Goes backwards 3 places, so we use -3. And that has the effect of dividing 5.9 by 10 3 times. This is really going to show why scientific notation is better. In this case, I'm starting with scientific notation, and I'm asking you to expand it into its original form. So I'm going to put, since it's a negative exponent, this is a very, very tiny, tiny number. So I'm going to start with the 4 and the 2 way over here. If the decimal starts between them and moves 23 times backwards, one of the times is just getting on the other side of the 4, right? So I'm going to count that 1, and then I'm going to count with zeros for the rest of the places, and you can watch. So 1, okay. Who wants to write it like that? Not me, that's for sure. It would be really easy to make an error. I don't even want to recount to make sure I didn't, but you should. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23 places different. So that's the expanded form. Okay, how about this one? So we've got 4, 0, 0, 7, 4, 3, and we need to move the decimal 9 times to the right. It started here, so 1, 2, 3, 4, 5, 6, 7, 8, 9. And so my number is, looks like 4,007,430,000. And that is the circumference of the Earth in centimeters, if you ever wanted to count them. And that's how scientific notation works.